In the previous reactions where we converted OH to a halogen like Cl and Br, what we were doing is turning that OH into a good leaving group because halogens are good leaving groups. Now we're going to do something similar by converting an OH to a tosylate. This is a little different in that instead of replacing the OH with something, we're going to just add this TS group to the oxygen. So let me draw the product here for you. So we're going to take this alcohol, add the Tosyl chloride and pyridine. And on this oxygen, we end up with the TS group bonded. And this OTS is a good leaving group. It's very similar to a halogen in that regard. But here's an interesting thing about this reaction. The stereochemistry of the starting material is retained in the product. So for example, if this OH were to be on a wedge, the OTS group would also be on a wedge. So that's a little different than when you added PCl3 or PBr3 where the stereochemistry was inverted. So let's look at the structures and the mechanism. So I'm going to start with an alcohol, and I'm going to simplify it just a little bit and just write this as ROH. Now let's draw Tosyl chloride. So this is kind of a bigger structure. So we have a sulfur with two double bond O's, a Cl, and a toluene group. So Tosyl chloride is actually para-toluene sulfonyl chloride. In the first step of the reaction, what happens is a lone pair on the oxygen forms a bond with the sulfur. And as it does that, it pushes a pair of electrons up onto the oxygen. So here's the new bond. We have the sulfur double bonded to one O, the Cl, O minus, and the toluene group, I'm just going to abbreviate that as TOL. And we have a positive charge on that oxygen. Now you'll notice that in this reaction we also have pyridine present. And you should know the structure of pyridine. We've discussed that before. Pyridine is a base. So what happens next is the pyridine gets involved. And the lone pair on that nitrogen acts as a base, and it just takes the proton off of the oxygen to make it neutral. So now we're left with R, the O, and the sulfur. The byproduct of this step is the pyridinium ion. So we have the protonated pyridine. So I'll just draw it. NH+. Okay, so we're still not at a neutral structure because we have the O minus. So the next thing that happens is this O minus, the negative charge of the electrons on that oxygen, those come back down to form the double bond, and then you lose Cl as a leaving group from the sulfur. So what we end up with next is the S double bond O, and the toluene group. Then the Cl minus that we lost, we'll just draw it here. And what it does is it goes and hangs out with the pyridinium ion that's in the solution to form a salt. So we have N plus, Cl minus, those two things hang out together. In our product, the full structure is drawn right now, but this SO2 toluene group is the Tosyl group. So we can abbreviate this like that.